Empowering your team to move fast. Here on Programming with Palermo.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
Welcome to another episode of Programming with Palermo. I am Jeffrey Palermo, your host. And today on the show, we're going to talk about empowering your team to move fast. And if you are an architect, if you basically run a software team, if you lead them, if they look up to you to set direction, whether they formally report to you for performance reviews, or even if you're not management, if you're the lead developer, whatever titles, you kind of have to steer a group of developers in a certain direction, then this episode is for you, because there's some important concepts in empowering teams to reliably move fast over time. And there's some main things that will just suck away your capacity, suck away the ability to produce throughput, and take that throughput and waste it so that you don't actually achieve velocity or any sort of return on investment for the software team. So let's begin and let's talk about empowering your team to move fast. We want to programming with Palermo. Okay, moving fast. So you are in an architectural flow team. Now you could be the lead developer, the development manager, lead engineer, architect, etc., whatever it is. You are the leader of the team of developers. And when I say architect, I'm referring to you. Let's talk about a few terms. Throughput. Okay, talking about moving fast. So let's talk about throughput first. Throughput is the number of items passing through a process. Let's say Ford Motor Company produces a new F-150 truck every 52 seconds. Then that's 1,600 per day. And if you're running 24 hours a day, okay, you should know how many features or software changes your team can deliver in a year. And if your team has completed, say, 77 items in the last 6 months, then you can count on probably about 3 per week. Architects who don't measure or forecast their team's throughput might bump at this measure, saying that, hey, maybe some features are bigger than others, and they're all the same size. You can't compare them apples to apples. They'll be right. But if you throw up your hands and say, well, I don't know how to forecast my team's throughput, well, you still haven't gained the way to set expectations, and you still have no idea what your team's throughput is. So we need a way to know how many software changes that a team can deliver. Your team can deliver. And as a leader, you have to know and you have to be able to report this to top leadership at your company. So we're going to walk through how to do this in this episode. Let's kind of decipher a few things. We just talked about throughput. That's the items per unit of time. Now, let's separate that from velocity. Velocity is distance over time. And these calculations are different. In the perfect world, throughput would equal velocity because there's no waste, there's no rework, and the different phases of the average movement between velocity has a little bit of seasoning to it. But let's talk about why it's not always the case, or it's not commonly the case, that velocity benefits from all the throughput that a team can get with. So velocity in physics is speed in a certain direction, and therefore it's distance covered divided by time. It's not total throughput. If I'm going to go from Austin to Houston, and there was a highway that took me straight there, then the total mileage I put on my car would be equal to the distance that I'd actually accomplished, actually traveled. With the various roads, the mileage that I put on my car, I actually had to drive more miles than I was able to travel just because of that dynamic. It's the same thing. It's the same thing in software. So we frequently see that some of the team's throughput ends up being waste. Just like some of the miles we put on our car is waste because we have to go have to find a bridge or have to go around a lake or the highways took us a certain way. All right, that's just the case. In 2009, Puppet Labs put out a software industry survey, state of DevOps, and we learned that the average batting average for a product manager or product owner was about 33%. What does that mean? That means a third of the time they were right to prioritize a certain feature or certain trend, and then two-thirds of the time they were wrong. Or if you dig into it, about a third of the time the change that was prioritized made no difference with the users and the customers. It didn't actually do what they were expecting to do. And then another third of the time, the change had to be backed out because it actually did the wrong thing. It actually made the software worse. And so only one third of the time was the product owner right. And so that survey kind of shed some light on the expectations that we can put on a scrum product owner or anyone in the product management role, and expecting them to, just because they're in that role, to have a perfect batting average. That's not really reasonable. So what does it mean for your team? That means that two-thirds of the work that your team delivered, two-thirds of the throughput of the items delivered out to production were wasted. That work should have never been done. The throughput was not aimed in the right direction, so we didn't actually cover the distance that we expected. And this affects our velocity equation. The calculation of velocity in Scrum assumed that the product owner would always prioritize the items that would have the most value, and what we've seen is that two-thirds of the time, something prioritized didn't deliver the value that was expected. But let's talk about another concept, affecting velocity. Affecting velocity by way of throughput, and that's wasted capacity. When the capacity is wasted, it's not put towards throughput. Let's illustrate. So consider when a production issue happens. It does. Production goes down, business disruption, maybe it's slowed, any kind of trouble ticket that gets escalated to the development team. When a member of the software engineering team has to divert effort to solving a production issue, the available capacity of the team for delivering software goes down. And over my career, I've seen systems sufficiently unstable that almost all of the developers were fixing production bugs or diagnosing production issues. Yeah. And a lot of you watching, you've seen at least one scenario that's like that. The end result is that the business is funding a software team but it's only benefiting from the throughput of maybe 20% of the team, and then if only a third of the throughput goes in the right direction because of the track record of things we've developed, we could be in a situation where only 7% of the progress is actually derived from the entire investment in the team. And when I speak of investment, I'm talking about the payroll of the team plus the cost of training and tools. A business does have a certain cost to maintaining a software team. That's the ongoing investment into the team, expecting to get a return from software. And let's talk about another concept, meetings. Computer World, in 2012 magazine, reported that developers spend about 11 hours per week in meetings, and another 6 hours per week just doing other random stuff other than working on the software. That's 42% of a normal work week. Right? So, you're the architect. You're the leader of your software team. You need to know the capacity of your team available to put towards software delivery. And if it's lower than what you want, initiate those conversations in your company or make the changes that you control independently. This is a big issue. Okay. So before we tackle the problem with velocity, we have to maximize our throughput. That's a big component. One aspect of maximizing the throughput is to minimize the work that's necessary in order to change the software, in order to get any particular feature, any particular code done. This forces us to tackle the issue that, like I mentioned before, not all features are the same level of effort. Okay? Things are different. Some big features, some small features. Some changes are just fixing a spelling error, others are wholesale change. Okay? I get that. The DORA organization, DORA, if you haven't heard of it, look it up. They do DevOps reporting, and that's shown that high-performing teams in our industry make a habit of deploying software more frequently, with the highest performing teams deploying at least weekly. Right? So in order to do that, those teams find ways not to have software changes take a full week of just killing. From a practical perspective, I tend to coach the planning of changes that should take an engineer no more than 1 day. Before you say, oh, that's unreasonable, that can never happen, there's always going to be outliers. But knowing that there will be exceptions, I tend to coach to target 1 day, and then the exceptions will sometimes end up being 2 days. But I don't want the norm or the planning to be changes that are expected to take 2 days, because then the exceptions, or when we estimate poorly, are going to take 4 days or more. Now, this does force more effort into the design of items of bigger things and breaking them down into multiple parts and focus on team patterns. But when engineers take an issue or a code or a story, whatever you want to name it, then they should know at that time how they're going to tackle it to make the change. The patterns that they're going to use, the technologies that they're going to use, those decisions to be established before a team member starts to think about the code that's going to be written. For new and novel items, designate them as R&D, research and development, or experimentation, or a research spike, whatever you want to call it. Put a time box around it and constrain the amount of capacity that you're willing to allow for experimentation, just like the scientific method. If it doesn't fall into place nicely within a certain small window that you specify, say that's a failed experiment, and guess what? We need to take a different approach.
Programming with Palermo is brought to you by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, ClearMeasure can help, while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
New and unproven technology or patterns can have a way of sucking team capacity without really yielding a return on investment. And just because other teams, maybe in your own company, other teams out there in the marketplace, maybe they report using a new technology or a new pattern or technique, and they say, oh yeah, it's great, and they report good results. That doesn't mean that your team is going to get the same results. Because maybe your team needs some more training, or maybe they need to be equipped in a different way before automatically being able to leverage the new thing. That's just reality. If a user feature, I'll close this topic with this. If a user feature needs to be broken up into, say, 10 issues in your work tracking tool, go for it. Do it. That's the right thing. Then you have a way to keep things moving, measure the throughput, and detect bottlenecks early. Okay? Don't just assign an individual some big feature and you want to work on it for 1-2 weeks and expect everything to be hunky-dory. It doesn't tend to be that way. Okay? And with small issues, with a known way to approach them, your team will end up minimizing the effort to any given change. Right? Another mindset that I advise you to have is to minimize the changes prioritized. You're the leader. Question everything. If product management is wrong 2/3 of the time, then you as the architect need to do your job and not just passively let your team work on 2/3 of the wrong stuff. Dig in and find ways to deduce which 2/3 are going to be wasted. You're the team leader. Work with product management to do something small as an experiment before committing to do a lot of the work in that direction. In my book, .NET DevOps for Azure, I discuss this very interesting starting on page 9. So you can go check that out. Let's next talk about bottlenecks. Right? We're trying to move fast. Bottlenecks can be fast. You want to create an environment for your team that helps you identify bottlenecks quickly. Now, work tracking tools, they're great, but most work tracking tools provide a Kanban-style board with columns like not started, in progress, and done. Just 3 statuses. It's great for super small teams, but it's woefully insufficient as teams add members and get larger. Each type of work should have a column dedicated to it. The columns are your statuses. And when you do that, only then can you tell what type of work looks like a bottleneck, or it looks like things are stacking up. Before code can be written, there's typically 4 types of design decisions that have to be made. When these 4 are called out, we can't tell an engineer. When these 4 are not called out explicitly, then you can't tell why an engineer is stuck on a particular item or why nothing seems to be moving through. So just to give you a sneak peek, I don't have time to go into this in depth, but if you have questions, just email programming@palermo.network, send an email. All right, 4 design decisions that really have to be made before something is ready for a programmer to start writing the code. First is, why this change is important. What are we trying to accomplish? For business objectives. Second is, how can the user use this new change or feature? This is typically where you have storyboard, or where's the button going to be, the flow of pages, the flow of screens, things like that. The third is, what technologies or patterns are we going to leverage in coding this change? Or is it something that we've done 10 times before and we already know the patterns, we already know the tools? Great. If it's not, we need to decide before expecting to put hands on keyboard and start writing the code. The fourth is, what user scenarios should be supported in the software for this change? This 4th decision serves as the user flows through the software to check to know that a change is fully implemented and functioning properly. And I advocate for pull requests. When you're evaluating a pull request, when a particular team member says, hey, this particular thing is done, here's all the code, how do you know what to check to see if you want to accept that pull request? Okay? How does product management know, what pathways? And how do we know we're done? Okay? This is our definition of done. But the user scenarios, it also supports full system acceptance testing because you have an explicit number of scenarios to the software. Those are the 4 design decisions that have to be made before we can properly write the code. And if we don't call them out specifically, then each developer is going to make those decisions according to the personnel. I've seen many teams leave one or more of these decisions to the engineers and then have trouble with slow-moving projects. And then everyone's frustrated because overtime starts to mount up, weekend work starts, everyone's losing sleep, coming in early, staying late, but the team is moving slow. Why? Not because of a lack of effort, but because of a lack of process. You're the leader. This is your job. Okay? Let's close with this. New project mistakes. Another big barrier to a team being able to move fast. New project mistakes. New software projects are just like life. The decisions that you make in the first 25% of your life have a huge and disproportionate impact on the results that you get on the last 75% of your life. And the same thing with new software projects. At the beginning of a new application, you're making decisions about software architecture, the tools you're going to use, the patterns you're going to use, the practices that your team is going to use, the structure and layout of your development environment. All these things are made in the first 25% of the project. Some of them are made in the first 5% of the project. But from day one of a new project, get the fundamentals in place or you will regret it quickly and for the rest of the life of the software. And what are the fundamentals? Well, read my book. There's a lot of them in there, DevOps for Azure. But test-driven development is one of the fundamentals. Multiple test suites of cascading types of automated tests. Continuous integration. Actual continuous integration. I'm not just talking about a triggered compile or pointing a tool to a code repository and say, compile my code every time something changes. That's like a small fraction of continuous integration. You don't know what I'm talking about? Read the 2006 book titled Continuous Integration. Okay? It's a full-fledged practice. Use continuous integration. Next, automated deployments. From day one, through the minimum of three environments. You're never going to have an application with fewer than 3 environments. The TDD environment, the UAT environment, and the production environment. Everybody knows production, and UAT is a pretty common name for a manual test environment. Some people like to use the word staging. But then before that, you need a TDD environment, and it kind of inverts the test and development mindset. But you need a fully deployed environment for all of your full system acceptance tests to run. No manual testing on this environment. It's a fully deployed environment where tons of automated tests are going to run. So that you know if it's even worth it to deploy to the UAT environment. Okay? You also need to have operational telemetry from day one in your environments. Operational telemetry, so you know in that environment, for that software, everything the software is doing, everything that users of that software is doing. Then you need a team scorecard. You're going to know your throughput, you're going to know your velocity, and you're going to know your capacity. You're going to measure it, analyze it, forecast it, and then tune it, make the changes so you optimize it over time. Okay? Every leader in any type of business has some type of scorecard. And if you're in a leadership role, and you're an architect, you need a scorecard. Now, it's going to vary from time to time. If you want a template of some scorecards that I like, just ask, let me know. You have to help you out with that, but you need a scorecard. All right, so I hope I've woken up some of you who are in an architect leadership role. You can have great developers on your team, but it's your job to bring that greatness into the software and out to your software's customers and users. So I'll leave you with this. You can do it. You have what it takes. You're an architect. Your team is counting on you to lead. You can do it. Now go do it. I hope this helps you, architect. Whether or not your job title is architect or lead engineer or development manager or you're kind of in the trenches with your team, if you are leading people who are writing code all day long, if software engineers report to you, then this is for you. How to empower your team to move fast. And we just scratched the surface. There is so much to this, and we're going to dive more into it. But I hope that helps. I want to leave you with encouragement. You are an architect. You're the leader. You can do it. Now go do it. God bless you. Thanks for programming with Palermo.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at Palermo.network as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.